I put that boot down in there in the hole, and because this little section was tore out here that goes across the top of this hole, or the bottom of it in this case on the left hand side, I put a little bit of RTV in there to help fill that gap up a little bit and maybe seal that up a little bit better. And then there's a pretty good gap around this dust shield on this lug here, so I run RTV all the way around that, through that gap. Hopefully that'll help keep some of the moisture and dirt from coming through that area. Now I'm trying to figure out some way to keep the crud from building up inside this actuator lever and freezing it up. There's a pretty good gap that would rust up there between that pin and this housing here, this portion of it here, on both sides, and then it also builds up between the lever and the housing, outside housing. I don't want to put grease in there. Grease will just absorb moisture and dirt, and there's also a chance of it when it gets hot, or even just the centrifugal force of it spinning it out of there and getting on those brake shoes. And the last thing you need to do is put grease on your brakes, even if it's just a parking brake. Well, I'm just taking a gob of this anti-seize, putting it on the end of my brush, and then putting it in there, and then it's got a gap in there between the two lever and the housing, and it just gently push that brush down there to try to tamp that stuff and press it in. It's just like packing a bearing, getting the grease to go in the bearing in all those places. You just gently keep packing it and slapping it until it gets down and fills all the cavities, and you can see it's coming out through the bottom there now. I was hoping to see it come out around that pin, but it's not doing that. Never seizes nasty stuff. It gets a little bit, goes a long ways, and it just keeps going and going and going. There. See, now it's pushing out around that shaft there. That's good. That's what I wanted. I want to do one more thing with this. Got some cosmoline here I'm going to put on here, especially on this section here where it got all pitted, but I'm going to coat it with cosmoline. The advantage of cosmoline over oil, as the carrier in that, the mineral oil or whatever in that dries out, this stuff forms a solid surface, and the moisture can't penetrate it. It doesn't pick up dust and dirt like grease does, and it doesn't pick up moisture, so it forms a barrier to moisture. Now this oil, preservative that they put on some of these Chinese goods that you get from Harbor Freight and other places, that's not cosmoline. That's just some dirty bilge oil or something that they get, that they spread on everything. It does a fairly good job of coating stuff to keep it from rusting while it's in being transported and storage and stuff, but it's not cosmoline. Now you notice this cosmoline here goes on pretty soft, pretty easy, but once it dries out, once the mineral oil that's in it that's keeping it soft flashes off, it hardens right up. So I'm going to leave this stuff out in the air here to harden up before I put everything else back together. Got new brake pads here. We'll put these on, and this thing can go back on the truck once I get everything else back on. Well, this cosmoline on this thing didn't dry out like I expected it to. I've been using peralketone quite a bit on stuff. It's supposed to be really similar to cosmoline, but it seems like it hardens up a lot faster than the cosmoline does. You get a pair of brake shoes here. I've got the new adjuster. I'm going to go ahead and spray some. Whoa, that thing really shot out of there. white lithium grease on there, put the star wheel on, and then that goes right here. Wipe my hands and make sure I get all the grease off of it before touching those. We've got this little spring in this hole right there, and then in this hole right here. I can spread this apart, put this adjuster in there, and close that back up. It won't stay closed. When we have this spring here, and this goes right in there like that. In this hole, and it goes the same way in this other side, in this other shoe. So the shoes go like that. Now they're held together, and now I can put one side of this on this activator. There we go. Just bring it like that. Now we got these pins come through the back side. Now those shoes like that just come out that side. They have these spring retainers. Okay, there, that is set up. A little fuzz down in there. Alright, so this brake is all set up. If I pull this handle now, you can see how that moves that brake shoe out. So that's working like it's supposed to now. We'll have to adjust this. Here's the retainers. Okay, put a little bit of grease down here on this pad where this slides on both sides. But these springs here have a tendency to rust off, and they fail here where they attach. And then when they do, the vibration and stuff, these adjusters drop out, and then they get tumbling around inside that brake hub and jam up. I've had known of them locking up the rear wheel just because those things get jammed up, and of course the shoes get pushed out and wore off, and anyway, there's a lot of stuff that's a mess in here just from corrosion. So I'm going to try to mitigate that by coating everything in here with this Cosmoline. You can thin this down with mineral oil and get it pretty thin. You can even spray it on with a spray gun. Get a nice even thin coat on everything. Okay. Now that looks like crap. I'll give it a minute. Hey, now that Cosmoline has flowed into all the cracks and crevices in that thing, and it'll cool off and solidify, and everything is pretty well protected with that. So we got sandblasted down to bare metal, corrosion proofing resistant primer, and then a primer overcoat, and then Cosmoline over the top of that. Hopefully that's protected pretty good. There's one assembly rebuilt. I didn't put new shoes on it. I put those on a couple years ago, and then I never did get the shoes adjusted to where they would work. I thought that I was, but it may be that this actuator lever was just froze up, and it wouldn't let it work. That thing is kind of a nasty mess, but it works now. That one can go on the truck. That one's ready. Good deal too. My wife just got back from Juneau and got me a new headlamp. Seems like it's working pretty good. I've never used one much before. We got this park and brake cable. I squirted a little bit of lube on it. I don't know how much got into the cable and how much is just on the spring there, but I tried. So anyway, we'll get this put on, and that goes in this lever right here, and then we got to struggle to get it through this keeper right there. So yeah, that part went pretty good, and now we got to get it. I've got to get the spring back here so that they can get that cable down through this notch in this keeper right there. So we'll see if we can't figure out a way to do that. Maybe it'll be easier going together than it was coming apart. Now the one thing we've got going for us is the lever works now where it didn't before. I try to use that lock there for a lever to lever that spring. There we go. That did it. That did it. Okay. There we go. That did it. I put the needle nose down over that spring. Use that for this block for a lever to compress the spring, and then pulled back against it, and that popped that. Give me enough cable space to drop down through that slot, and then it popped in there. And now, as they say, somebody says, I don't know, I never said that, but Bob's your uncle. Never could understand that saying, but Bob was my uncle. Okay, now I take that cable and put it down underneath that. And there we go. Just like it was meant to fit there. Okay. Now, of course, this one, the top one, that was the one that we couldn't get to move hardly. Couldn't get enough room on it with the wrench to get any twist on it. I'm up against the locking portion of the nut now so that it won't spin on any farther by hand. Put a bar on those and put a little bit more torque on them here a little bit later. But that piece is on. Hey, that's cool. Oh yeah, I'm happy with that. I get both sides and get them parking brakes working, and now those things are going to last a little while longer, I think. They're not going to be falling apart in the next year or so. The brake assemblies are all together and installed on the truck, and the next step is to put the hubs on there, put the bearings in the hubs and the seals on them, and put the hubs on. And one of the things about to put the hubs on is you need to put the axles on. You want to, once you put the hub in and the front bearing on and the nut and get them all down preloaded and everything, and you want to put the axle in there to cover this hole up so you don't get crud in there while you're doing other things. Well, the axle had a seal between it and the hub, and it's one of the few things on a vehicle anymore that actually has a gasket in it. Most things anymore, they put RTV in. They make gaskets out of RTV, and it's real easy to use because you just spread a little RTV on there, slap the two parts together, and bolt them down. But it doesn't make an ideal gasket. Some places they've been outlawed. The FAA has pretty much outlawed them on most aviation uses. And what happens is the RTV, you spread it around on here, goop it on there pretty good, put your two pieces together, and bolt them down. And everybody wants to just assemble it right now, so they bolt them down, and it squeezes all the RTV out between the mating surfaces of the pieces, and you wind up with little balls and BBs and stuff hanging off of it on the inside and on the outside, and you don't wind up with a good gasket. You don't have a good seal between the two surfaces. If they start fretting or anything, it'll start leaking pretty soon. But what the real problem is those little balls and BBs that get squeezed out in there wind up breaking loose and going down into whatever area you're sealing off from. And if it happens to be a sealed oil chamber or gas, of course you can't use RTV and gas, but an oil chamber or something, the little BBs go down through there and they get plug up the oil chambers and ports and stuff and cause oil starvation in certain places. So we use gaskets still on some things, and this axle housing hub did use a gasket on it. Now, I learned a long time ago that if possible not to use any type of sealant with a gasket, just to use a gasket on there. And where you have a gasket, mating surfaces like this where they're solid steel, this is either cast steel or cast iron, probably cast steel. Anyway, you've got two solid surfaces going together and a good close bolt pattern between them. They'll squeeze down a gasket pretty good and make a good seal. Some places where you have softer material like a valve cover gasket, oil pan gasket, something like that, that's stamped steel or aluminum or something, it may not be as rigid, and so, oftentimes the bolt holes are farther apart, and so you don't get a good squeeze. You can't really torque it down to get a good squeeze on a gasket, and they will fail. So you can use RTV on those to help seal up between the gasket and the surface, mating surface. But ideally, you wouldn't use anything on there. Now these gaskets that they used on this axle and hub assembly, they were just glued down in 2 or 3 spots, probably to hold the gasket on while everything was being moved around before they put the axles together. And this one came off okay. It's got a couple little tears in it where we broke the sealant loose on it, but the one on the other hub, it tore up pretty good. Oh, and then this one here is squeezed out pretty good. It's pretty thin, and once it gets squeezed out, then when you put it on again, it doesn't compress near as well, so it doesn't seal the second time near as well. So I decided to make new gaskets for these, and this is it. Got a new gasket there. Well, this is the way I did it. Now, a case like this on this axle seal, this gasket came off in good shape, and it's not stretched out of shape or anything, so you can use it for a pattern and just lay out and cut out a new gasket, and that wouldn't be a problem. The other one was tore up, and so putting it together without it being distorted to make a pattern for a new gasket would be kind of problematic. And it'd be difficult to use this to make a pattern. You could lay it over like this and run a pencil line around it, cut it out, and maybe stick a pencil up inside to try to get around here, but getting a good accurate mark on there would be kind of difficult. And then you still have to figure out how to get the bolt patterns in. Well, this is the way that I learned years ago how to make a gasket. And you just take the paper and lay it over your area, and then take a hammer and just gently tap around it. And I'm using a drawing stroke across that pattern instead of just a direct hit. I'm just drawing across there. Now you want to make sure that the paper doesn't move on your item, or you won't get a good line. But you can see that's making a line there now. All the way around that. So we've got a line around there, most of the way around there. And now it'd be a simple matter of taking that off there and taking a pair of scissors or something and just cutting that out. Oh, that's fine. But what if you don't have a pair of scissors or a sharp knife? And actually a faster way of doing that is just to go ahead and take this hammer and just keep striking that paper. You don't want to hit it hard enough to peen over that edge and distort that edge. But if you just hit that paper and just keep drawing across it, it doesn't take much, and that paper will just come apart right there. Now once it's come apart, it makes it a little easier to position back on there because you have that, if it gets off just a little bit. There we go. A nice round cutout. Now what to do is locate the bolt holes. Basically you do that the same way. I can run my fingers across here and find where the bolt holes are. And if you put some Dykem on there or something like that, that would transfer the lines to the inside, and you can kind of see the little indentations where they're at there, and you could punch those out with a punch. But we hold that on there like that, just take the ball end of the ball peen hammer and gently strike that. Now you don't want to do it hard because you don't want to, again, peen over the edge of that hole, but there's a nice hole punched out. Now I've got that one in, I've got a bolt here. I'll go ahead and just set that one in there, that bolt in there like that, just to hold that in location, to make it a little easier to hold my location. I'm going to find another hole right there. The second one. Now if we're just making a flat cover plate to go over the end of that, that would be it. That would be good enough. But since we're not, we're putting an axle down through there, and the axle has got to fit down through that opening, so we need to open that up. Well, I just take the ball end and just gently go around this, holding this down. Now I've got a location for my inside perimeter, the inside line on this, and I could just go ahead and take that off and cut that out with a knife, or I can just go ahead and keep doing this. It doesn't take a whole lot to cut that paper. There we go. Nice paper gasket. Not quite as pretty as a laser cut one, but it'll do. To open this up enough to get everything off from the rotors in the first place, I just stuck a screwdriver in there in that carrier between the pads and the rotor, and just kind of pried on it enough to get those pistons in, so you get enough clearance to get that out of there. So, but we're gonna be putting new pads in there, and of course these pads were worn down pretty good here. This one's just about gone. So these pistons stick out a long ways, and because they stick out so far, you're going to have to get them to go back in to get the new pads in there. So I've got one of the old pads here. Stick it in there to double up between the two pistons. I've just got a 4-inch C-clamp, and they make special tools for this, for putting those pistons in, and they're not too expensive. I think you can get them, depending on where you get them, for just a few bucks, 15, 20 bucks, something like that. But already got the C-clamp, and I put this old piston, old brake pad in there just so that I can compress both pistons at the same time. If you do them one at a time, there's hydraulic pressure, hydraulic fluid, brake fluid in each one of these pistons, and if you do them one at a time, that brake fluid's got to push all the way back up into the master brake cylinder, and it's going to take the path of least resistance. So there's a good possibility if you push this piston in that this piston will just pop out of there. So to prevent that, I want to do them both at the same time. There we go. That takes a little bit of pressure to do that, because you do it slow, as you're pushing all that fluid all the way back up through that whole system into the master cylinder. Those pistons are pushed up in there now, so we've got plenty of room to put that carrier on there with the new pads in there. Getting ready to put those rear hubs on, and I've got to put the nuts back on to these nuts. This is one of the rear nuts, and it goes on and preloads the bearings and holds it, basically holds the hub on. And when I took those off, I was able to get them loose with just using a couple of pin punches sticking in to these holes on this nut, and then taking a bar and spinning them off. In fact, the one on the left hand side was just basically finger tight. Putting them back on again, you have to press on the seal. It's not just like a normal seal on a greased hub. It's just a rubber lip, and it just slides on over an area that's machined out on it that it spins around on. But these are oil-filled hubs, so they're two-part seal, and the rubber lip spins around inside of another part of the seal, and that portion of the seal has to press itself onto the portion of the spindle. So that takes a little bit of force getting that on there, and then getting the right preload on those bearings and everything. I decided I probably would be well advised to have some sort of a spanner to put some torque on those. Now we're looking at different options of making one. Of course, this is a little spanner that comes from my one of my 4.5-inch grinders, and that didn't really work. Come close, it would fit in there on 2 of those, but it really won't. This nut is kind of recessed inside that hub, so you have to get something that'll reach inside that hub, and this is pretty flat, and it wouldn't do it, and it doesn't give me much purchase on there anyway. So I was looking at different options of how to make some kind of a spanner. I was looking at the metal I had. I was thinking I could take a piece of tubing and either cut it down if it was big enough and leave some ears on it, little tits sticking out of it to fit into those holes, into these receptacles here on this. They're just 1/4-inch drilled holes, and I didn't have anything that would fit there. I save all kinds of junk, and this is a wire wheel I use on the 4.5-inch grinder. This one's pretty much wore out, and I've had another one on it. I thought, well, maybe this is about the right diameter, maybe I can do something with this. So I took a die grinder with some grinding pad on it and ground out this little relief right here, and I was able to pop this center section out, and that exposed the wires, and they just go through a steel disc like this, and they go up, the bundle of wire goes through each one of these holes in this disc and out, and that's what makes the wire wheel. And so I thought, well, I tried those out, and it looked like they'd line up. Well, I took this disc out, cleaned all the old wire off of it and stuff, and put it up there, and it wouldn't quite line up. These holes are in a different pattern on there, and they just don't quite line up with that. Oh, I thought about taking this portion of it that was left over and drilling holes in it and try to weld something on. I was looking at other different options, maybe cutting out a piece of aluminum here and pressing some pins in it, or different odds and ends. Well, I got to checking with my hole saws, and this is a cheap hole saw set that I had. and I got to trying these up against it, and this 2 1/4 inch hole saw is just the ideal diameter to fit on the inside of those drilled out sections of that nut. I've got some 1/4 inch rod. I've taken some 1/4 inch rod and cut off into short little chunks, and right now I've taken those and set them into the sockets on that nut, and I've got 2 of them on there right now. I just tack welded them on, and to hold them into position while I did that, I used a couple of these little neodymium magnets, and that one is no longer magnetic. It got too hot. This one has lost some of its force, so they're sacrificial, but they were cheap and they did the job there. They held those pins on until I could get the spot welds on them. Now I'm going to take that off out of the vise here now. I'm just going to roll that over 180 degrees and leave that in those sockets right there. I could have got by with just 2 of those pins, 1 on each side maybe, but I think 4 of them would be a lot better. I put that pin in there like that. Let's see if that magnet will hold it, since I've already sacrificed that. I want to hold that one. This pin is a little bit long, but and that magnet will just got enough to hold that up there. So I'll go ahead and tack those 2 pins on there, and that'll give me a spanner for that. Then I'll have to figure out some way to get a wrench on it. This is the axle nut for the rear axle on the Dodge 3/4 ton pickup, and this is my spanner, and I think that should work. I was going to weld that nut on. See, this is the side of the nut that got ground out and then punched out of that wire wheel. I was going to weld it on with that side down, but I decided it was probably better to weld it on the flat side down. That still gives me enough room on there to get a wrench on it. In fact, I can probably get a socket on there now, and that'll be better. So that should be a pretty nice, a lot better way of trying to spin that nut on there than trying to do it with a chisel. We'll see how it works.